Well, hello again, everyone. Mr. Reeves back with you. And this is my third video in the series of looking at polygons and the area of polygons, more specifically looking at quadrilaterals and triangles. All right, so in the previous video, we took a look at these area formulas, and we went over kind of where these formulas came from and why they are what they are. And in this video, we're just going to go ahead and dive in and do some problems where we're going to be finding areas. So let's go ahead now and see if we can take a look at finding the area first of this shape. Hopefully when you look at it, you recognize that this is a quadrilateral because it has four sides. More specifically, hopefully you recognize that this is indeed a rectangle. What makes it a rectangle? Right angle, right angle, right angle, right angle. Opposite sides are parallel. That's what makes it a parallelogram. And congruent. So this side is 6, this side would also be 6. This side is 8, and this side is 8. All right. And as we were doing, if we were to stop real quick and go ahead and take a look at the formulas, right here, what do we have for a rectangle? It is length times width. It is length times width. So if we go back here, back to our rectangle, and we want to find the area is going to be the length times the width. And the easy thing about the rectangle is you just pick one of these, either one. The length can be 6 or 8, by the way, and the width is 8 right here. Generally, we talk about this as the width and this is the length, although if you turn your head sideways, it's the other way. So the area is 48. But 48 what? Remember, another thing we talked about earlier was we want to fill this shape with squares. I know these aren't very good squares, but the question is, how many of these squares would it take? And in this case, each one of those squares would be a centimeter by a centimeter. So it would be a square centimeter. So when you find area, the units are always squared. All right, the question is, what are you squaring? In this case, as the problem says, they are square centimeters. So there's different ways to write that. The easiest, shortest way is to write it that way. So the area of this one would be 48 square centimeters. And if we were on IXL right now, we'd put that in and it would tell us that we did a good job. So rectangle right here, length times width, and don't forget the units are always squared. All right, so that is finding the area of a rectangle. What do we have next? Whoa, we have a square. Now again, hopefully you remember and you know that a square is just a special type of rectangle. We still have, what do we have right here? We have these right angles, right? We still have this side parallel to this side, and this side parallel to this side. We still have this side equal to that side, right? But what's different on a square? All the sides are the same. So again, the formula could be base times height. The formula could be length times width. But if we go back and we take a look at the formula that we have, area is the side squared. Area is the side squared. So if we take a look here, the side is what? The side is 9. So it's 9 squared, and 9 times 9, I hope you don't need a calculator, is 81. But again, the question is, what are our units? They are feet, right? So it's actually 9 feet times 9 feet, if you think about it, right? And 9 times 9 is 81. What's a foot times a foot? Well, it's a square foot. Again, we are filling this shape with squares, only now it's a foot times a foot. So we get a square. It's not really to scale, is it? But it's a square foot like that. All right, so the answer for this one, let's see if I can fit it in right here, would be 81 square feet. All right, so there's how you find the area of a square. All right, so what do we have next? We've done a rectangle, we've done a square. Our next one, what is this, ladies and gentlemen? Do you recognize it? This is that's right, parallelogram. So how do we recognize this parallelogram? Well, that side and that side are parallel, and that side and that side are parallel. But what's different about this versus the rectangle or the square? What don't we have? We don't have those right angles there, right? Which means then our height is not one of the sides. If you watch my other video, remember I said the height is the distance between the bases right here. So we have to go straight down and make that a right angle. So our right angle, we still have that right angle, right? But the difference between this and a square and a rectangle, on a square and a rectangle, that right angle was part of the shape. Now it's not. All right, so what is the formula for the area of a parallelogram? Well, the formula for the area of a parallelogram, here it is, base times height. Base times height. So let's go back here now. We have base times height. So our base right here is 3, and our height right here is 2. So the area is going to be 3 centimeters, and this time I'm actually going to put the units when I do it, okay? So I'm going to put 3 centimeters times 2 centimeters. And again, 3 times 2 is 6, and a centimeter times a centimeter is going to give us that square centimeter. So we get 6 square centimeters. So if this were a centimeter and this were a centimeter, this right here is a what? It's a square centimeter, and we're saying we could fit 6 of these in there. Obviously, this one's too small because we could fit a lot more than 6 there. This is only supposed to be, what, 3 across? So those squares would be a lot bigger, right? Does that make sense? All right, so parallelogram, length times width. Again, just to bring your attention, I can't hit it hard enough. That height is the perpendicular distance between these two bases. By the way, there's another height we could find between these two bases, but it'd be a little more tricky because it would be outside. So they were nice enough to give us that one. All right, what do we have next after parallelogram? Whoa, we have a triangle. All right, what is our formula for the area of the triangle? Let's see here. 1/2 base times height. 1/2 base times height. Do you guys remember why? Let me just do a quick sketch here. See if I can do this quick sketch. All right, if I extend this bottom side and I put it up here, about like that, and I take this side and I put it over here, about like that, what do I get right here? I get another triangle, right? And these two triangles together make what? A parallelogram that we just did. And do you remember what this was in that parallelogram that we just did? That was the height, right? Yeah? And you remember what this one was? That was the base. And when we did the parallelogram, it was base times height. But now we only have what? We only have half of this. Because guess what? None of this is really there. It's gone, 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 gone. So we want what? We want our area to be 1/2 the base times the height, or 1/2 of 8 times 5. All right. Now we can do half of 8, which is 4 times 5 and get 20. Or we could do 8 times 5 is 40 and do half of that is 20. Multiplication is commutative. All right, so either way we get 20. And don't forget those units. It's meters, right? This was 8 meters times 8 meters. So it's 20 square meters, right? 20 square meters is what we have right here. All right, 20 square meters. The area of a triangle, 1/2 base times height. By the way, this triangle right here is an acute triangle. If you watch my last couple videos, I went over the 3 different types of triangles that you could classify by angles. In the first video, we also classified them by sides, but we don't have to worry about that when we're finding area. All right, so what do we have next? Bet you're dying to know. We have another triangle. No way. Another triangle. All right. This triangle is a right triangle. And the great thing about right triangles, right, is that the height is on the triangle. In fact, either one of these could be the height and either one of these could be the base because there's that magic square right there. All right, but since they drew it this way, let's go ahead and label this one as our height and this one as our base. The area of a triangle is 1/2 of the base times the height. Again, I could do the same thing I did in that last triangle. I could draw another one right here, and it would make a rectangle that was 6 by 8. So it's 1/2 of, what did we say, 8 times 6. And again, you could do half of 8 is 4 times 6 is 24, or you can do 8 times 6 is 48 and take half of that, and you get 24. But don't forget, we're looking for square units. What are the units? The units are miles. So we get 24 square miles. 24 square miles. And we did it. Right triangle. It's the same formula as we used for this one, right? It's still half base times height, only this was an acute triangle. Let's make that a little neater. How about that? This was, oh my goodness, Mr. Reeves. This was an acute triangle, right? This is a right triangle. And an acute triangle, the height was on the inside. In a right triangle, the height is one of the sides, just like that. Okay, so we had an acute triangle, we had a right triangle. I'm hoping you know what's coming up next. That's right, no fooling you guys. We have right here an obtuse triangle. Why is it an obtuse triangle? Because this big old angle right here is obtuse. That means it is greater than 90, right? Now again, that height is key. We always have to find that height. Here's my height. All right? The height of a triangle is the distance between my base and the tippy top, right? Now, sometimes students might think that this would be the height, but that's a slanted height, right? If you're standing at an angle, if you're leaning, and you measure that, the height is going to be how tall it is straight up and down. Got it? Straight up and down, not this leaning part. So the height of this triangle is 4. It's not whatever this is, all right? So this is my height. Again, on obtuse triangles drawn this way, the height will be on the outside. All right, there actually is a way, like I said in the other video, you could actually draw a height on the inside in here like this. Whoops. And then this would be the base, and that would be the height, but they didn't do it that way. They did it this way. So this is my base, and that's my height. Again, for any triangle, does not matter what type of triangle. It's 1/2 the base times the height, because I could put these two triangles together and make a parallelogram, just like the other ones. Here we go. 1/2 of 6 times 4. Again, I can do half of 6 is 3. 3 times 4 is 12. Or I can do 6 times 4. Right here is 24 times the half is 12. Either way, I get 12. And what are my units? Centimeters times centimeters is square centimeters. So we get 12 square centimeters. Again, put that in IXL. It's going to say good job. All right, so what have we done? We did a rectangle, then we did a square, then we did a parallelogram. Now we've done 3 triangles. What's the one we haven't done yet? That's right, a trapezoid. All right, just a reminder, how do we recognize a trapezoid? A trapezoid has one pair of parallel sides and one pair that are not parallel. All right, so this side and this side are parallel. All right, just something to know, if you extend, remember how I was talking about in the previous videos, how there's a relationship between trapezoids and triangles, and unfortunately it's not going to fit on the screen. I'm really bummed. But if you extend the non-parallel sides of a trapezoid, I hope you can imagine up above here off the screen they're going to meet, you get a triangle. So I often say a trapezoid is like a triangle where the top part or the head has been removed. All right, kind of a gross idea, removing the head. Just forget I ever said that, all right? Okay, so we have this pair of parallel sides here, and then we have also this height. So right here we have this height inside here. All right, so this distance right here is going to be my height. So my height is equal to 7. Remember, the height is always perpendicular. You look for that. When you're looking for the height, look for that right angle. These are my bases. Now remember, though, in a trapezoid, you don't have one base, you have two. And we call one of them B1, and we call the other one B2. And again, you can call this one B2 and this one B1. It really doesn't matter. What was that formula again for a trapezoid? Let's get back there. Whoops. Here we go. This is what I was trying to get to. All right, a trapezoid is 1/2 times the height times base 1 plus base 2. Remember, triangles and trapezoids are really closely related. They both have the half. They both have the height. The only difference is a triangle only has one base and a trapezoid has two bases. Because again, I just referred to it. I told you to forget about it, and here I am. I'm bringing it back up again, right? There's a triangle. Okay. There's a, well, not such a great one. There's my sketch of a trapezoid, right? How do I get this from this? I simply draw a line across like this, right? I take this part away off the top, and what do I get? I get the trapezoid. And when I do that, what did I just do? Let's see, will it let me undo it here? Can I undo what I did? Oops. There we go, right? What did I have here? I had a base, correct? And when I took this away, what did I do? I created another base. So now I have to give those bases a last name, base 1 and base 2. But triangle, 1/2 base times height. Trapezoid, 1/2 the sum of the bases times the height. All right, so let's go back to where we were. Let's try to go back to where we were. Here we are. This is where we were. So the formula is going to be 1/2 times the sum of the bases times the height. By the way, on the book version, they put the height over here. I actually like putting it here because that keeps it the same as a triangle, right? Triangle is 1/2 base times height. Trapezoid is also 1/2 base times height. Only now we have to put those two bases together. All right, so here we go. 1/2 of, what are my bases? 4 plus 2 times, what is my height? 7. All right, so I have 1/2. According to order of operations, I need to add these two together. 6 times 7. Half of 6 is 3. 3 times 7 is 21. Once again, I could do 6 times 7 first and get 42, and then take half of that. What are my units? My units are square millimeters. So I get 21 square millimeters. All right, so this is a trapezoid. And by the way, it sure appears that that side and that side are the same length. When those two sides are the same length, we call it an isosceles trapezoid. So you often see trapezoids that are isosceles, but they don't all have to be. So if I look right here, here's an example of a trapezoid that is not isosceles. I hope you can see that this side is longer than this side. It's still a trapezoid. How do we recognize a trapezoid? It has one pair of parallel sides. Again, I can't make it fit, but if I extend the non-parallel sides, I would get a triangle, right? So if this goes up and this goes up, eventually they're going to meet and I'm going to have a triangle. So that trapezoid, you've just removed the top part of a triangle and you have made that trapezoid. All right. The base, right? The base is always the distance between the base. The base. My bad. The height. The height is the distance between the two bases on a quadrilateral. I should have really emphasized on a triangle. The height is the distance between the base and the tip, right? Let me just get to that because I really should have said that before. So the height of a triangle is the distance between the base and one of the tips. So I didn't really go through that, but every triangle actually has 3 bases and 3 heights, right? Okay, so here we go. So again, our formula for a trapezoid, it doesn't matter if it is a isosceles trapezoid or a non-isosceles trapezoid. It's 1/2 times the sum of the bases times the height. And again, I just want to point out to you that the book version of the formula, and this is the way you often see it. Man, where did it go? Why am I struggling here? Okay, they put the height here, right? But it doesn't matter if the height is there or if the height is there. I always do it this way because I like it to match the triangle. I like the half and at the beginning, I like the height at the end. And for a triangle, I have one base in the middle. And for the trapezoid, I have the sum of the 2 bases. Okay, so let's see if we can actually get back to where we were. Now, this is all crazy. I have no idea where I'm at. All right, we were doing the area of this. Wow, I got off far, didn't I? All right, so here we go. So I have 1/2. What are my bases? My bases are 10 and 5, and my height is 6. So 1/2 of 10 plus 5, because we're going to follow order of operations and add those together because they are inside the parentheses. 1/2 of 15 times 6. Now again, with multiplication, I could do half of 15 and get 7.5 and then multiply it by 6. Or I can do 6 times 15, which is 45, and then do half of that. Either way, I'm going to get 22.5. 22.5 square centimeters, right? Remember, area is always in square units. In this case, 22.5 square centimeters. Is that right? I'm doubting myself a little bit here. All right, so 15 times 6 would be 90. Ah, Mr. Reeves, Mr. Reeves, Mr. Reeves. I knew something was not right, right? So 3 times 15, what I actually did was, I took half of it twice. You don't need to know my mistake. All right, so if we did half of 15, we would get 7.5, and we could do 7.5 times 6, so that would be one option. All right, 15 times 6, right? If we did 15 times 3, we get 45, so 15 times 6 is 90. So we get half of 90. Well, for me, I'm better at doing half of 90 than I am at 7.5, and so it's actually 45. So I did a half of a half. I did it twice. You only do that half once. 45 square centimeters. I'm glad I caught that mistake so I didn't have to do this entire video all over again. All right, so that gets us to the end. We have done all of these now. We started off with a rectangle. We did length times width, then we did a square, which is still another version of length times width, but the length and the width are the same, so we do s squared. We did a parallelogram, which is base times height. Just a reminder, all of these 3 are actually parallelograms. These are just special versions of it, right? Then we did triangles. We did an acute triangle. We did a right triangle. We did an obtuse triangle. All of them have the same formula. And finally, we threw out the area of a couple trapezoids. All right, so I hope this helps you. Of course, if you need to, you can always go back and watch any part of this video again. If you get stuck on one of the problems you're doing, see if you can compare it to the type that I did. All right, thanks so much for watching. I hope you guys all have a great day.